Imagine a world without the ability to measure distances accurately. Construction projects would be haphazard, navigation would be imprecise, and our understanding of the universe would be severely limited. Thankfully, we have tools and principles that allow us to navigate and comprehend the world around us. One such fundamental concept in mathematics is the Pythagoras theorem. This elegant theorem has been a cornerstone of geometry and trigonometry for centuries, shaping our comprehension of space and measurement.
The Pythagoras theorem focuses on a specific type of triangle, the right-angled triangle. This triangle has one angle measuring precisely 90 degrees. The theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. The hypotenuse is the longest side of the triangle, located opposite the right angle. This simple yet profound statement can be represented mathematically as c squared equals a squared plus b squared. In this equation, c represents the length of the hypotenuse, while a and b represent the lengths of the other two sides, often called legs. This elegant formula allows us to calculate the unknown side length of a right-angled triangle when we know the lengths of the other two sides.
While the theorem bears the name of the Greek mathematician Pythagoras of Samos, its roots extend far beyond ancient Greece. Historical evidence suggests that civilizations like the Babylonians and Egyptians had a practical understanding of this mathematical principle long before Pythagoras formalized it. These ancient cultures utilized the principles of the theorem in construction, land surveying, and astronomy. Pythagoras, however, is credited with providing a rigorous mathematical proof of the theorem, cementing its place as a fundamental principle in geometry. His school of thought, the Pythagoreans, were captivated by the inherent beauty and order of numbers. They viewed the Pythagoras theorem as a testament to the harmony and elegance of the universe.
Section 4. Unveiling the formula. The beauty of the Pythagoras theorem lies in its simplicity and wide applicability. The formula, c squared equals a squared plus b squared, is deceptively straightforward, yet its implications are profound. Let's break down the formula. C represents the length of the hypotenuse, the longest side of the right-angled triangle, always situated opposite the right angle. The variables a and b represent the lengths of the other two sides, known as legs. To use the formula, simply substitute the known lengths of the sides into the equation. If you know the lengths of the two legs, A and B, you can calculate the length of the hypotenuse, C. Conversely, if you know the length of the hypotenuse of one leg, you can solve for the length of the other leg.
Section 5. Visualizing the proof. One of the most intuitive ways to grasp the Pythagoras theorem is through a visual demonstration. Imagine a right-angled triangle. Now picture squares drawn on each of its three sides. The square on the hypotenuse will have an area equal to the sum of the areas of the squares on the other two sides. This visual proof elegantly illustrates the core concept of the theorem. The area related to the hypotenuse directly corresponds to the combined areas related to the other two sides. This concept transcends a simple formula. It reveals a fundamental relationship between the sides of a right-angled triangle.
Section 6. Modern Significance and Applications. The legacy of the Pythagoras theorem extends far beyond the realm of theoretical mathematics. Its applications are deeply woven into our modern world.
Architects and engineers rely on the theorem for building design and structural integrity. Surveyors use it to determine distances and heights. Navigation systems, both on land and sea, depend on the principles of the Pythagoras theorem to calculate routes and distances. Even in the digital age, computer graphics and video game developers utilize the theorem to create realistic three-dimensional environments. The Pythagoras theorem, though ancient in origin, remains a fundamental pillar of modern science, technology, and our understanding of the world around us.